Welcome to this video. In this series of video, want to cover up the classical mechanics for the semester 1 of B.Sc Physics of University of Calcutta. In this video, want to discuss about the reference frame Galilean transformation. So look at the syllabus of the University of Calcutta first semester of B.Sc Physics. This is the syllabus for mechanics paper 2 of first semester, and in this video we want to cover up this portion. We can look at the total syllabus, the fundamental of dynamics, work and energy, and next is the gravitation and central force, non-inertia system, rotational dynamics and fluid motion. This is a total syllabus of the mechanics, and in this series of video we want to cover up this portion. In this video, we want to discuss about the review of the Newton's law, mechanistic view of the universe, concept of the inertia frame, force, mass, and Galilean transformation and the Galilean inversion. This portion we want to cover up in this video. So look at the one by one. Now we want to discuss first about the reference frame. What do you mean by reference frame? What is the need of the reference frame? Look into this matter. Suppose this is a bus. This is a bus. Suppose this is a bus, and there is two persons situated within the bus A and B. Clear? And the bus move with the speed 40 km/h. Simple. Now there is another person. There is another person C which are standing on the side of this road. Now, if we want to question that what is the state of B, moving or standing, rest or motion, motion or rest or motion? Simple question. If I want to question that what is the state of B, rest or motion, the state of B, is this state of B rest or is the state of the B is motion? Then you can say that is motion. But if I want to say that is rest, why? Think about with respect to B. If you are with respect to A, if you A, then your sideman will be in rest with respect to A. So the B will be rest with respect to A, right? Similarly, the B will be motion with respect to C. So we need to with respect to C. So motion or rest of any particle can be determined or can be stated with respect to any other person, any other system, right? Here the motion of B will be rest with respect to A, and here the motion of the B will be moving with respect to C. So the state of the B is rest as well as motion with respect to different person or different system, and this system or person is known as the reference frame. Reference frame, I think clear. Reference frame is the frame by which or with respect to we can describe any motion of others particle. This is the system with the reference system. With respect to that system we can describe the motion of the other particle. Okay, so here A is a system, reference system, and C also a reference system which describe the motion of B. Okay, these reference system are two types: inertia frame, reference system or reference frame, inertia frame, and another one is the non-inertia frame. Inertia frame. Inertia frame means this frame or the system whose have velocity will be 0 or velocity will be 0 or constant. velocity will be 0 or constant. The reference frame which have constant velocity or 0 velocity in the inertia frame, a non-inertia frame does not equal to constant. The velocity which is not equals to constant is known as non-inertia frame. Suppose there are very much number of non-inertia frames. Suppose our Earth is a non-inertia frame because its direction of velocity always changes, so the velocity will be changed, not constant. So this is a non-inertia frame, and this is a inertia frame whose velocity will be 0 or the constant. Suppose you have a bus with motion constant velocity, that is 40 kilometer per hour. So this will be taken as the here A is the inertia frame. You can see the A is the inertia frame, C also inertia frame. These two are for this is a rest and this is in the uniform speed. So that's why this is called the inertia frame. So I think clear what is the reference frame and type of reference frame. Two type, inertia reference frame and the non-inertia reference frame. We will be discuss about the effect of this inertia and non-inertia. Now come into the revision of the Newton's law of motion. You all know that three Newton's law of motion. This is a classical Newton's law of motion. First law, you know, if there is a inertia frame, you understand what do you mean by inertia frame of reference. An object either remain at the rest or continuous to move the constant velocity unless acted upon a force. Suppose this is a body. This body will be motion with the uniform velocity, or if we rest, they will be rest, yeah, unless acted upon a force. If we don't act upon the force of this body, if we don't act upon force on this body, then the body will be moved with its uniform velocity unless up to we can apply the force. Okay, without acting any force, the motion will be in uniform speed, or if is rest, there will be rest. First law. Second law says the inertia reference frame, the vector sum of the all forces of the object equal to the mass of the object multiplied by the acceleration of a of the body. You know very well, this is the force acting on this body. If this is a body with mass m, and if we apply the force, then the acceleration is related to the force, like that F is force equals to mass into acceleration. Okay, and third law, when one body exerted force on the second body simultaneously exerted the force equal and imaginary equal in magnitude, opposite in direction. That is, there is two body A and B. If A exerted a force F1 2, then B also give a same force with the negative, that is the direction will be opposite. Okay, so this is the Newton third law. This is a three law, you know. Okay, here you can conclude or you can say about the mass. If there is mass is enhanced, if we increase the mass, then the same acceleration will be produced, with the large external force. So for larger mass, you need to apply more force to produce the same acceleration. This is the concept of mass. And if you want to take about the concept of force also, this is similar. The physical parameter we need to apply to accelerate any particle. Accelerate means they change in the velocity. The particle whose velocity wants to change, then this is produce an acceleration, and this acceleration can be made by the applying force. And if we consider the larger mass body, so you need to apply more force with for the constant acceleration or the same acceleration if you wants to produce, right. Now came into the matter, that is the mechanistic view of the universal. That means in this universe, you say this is a sun and these are the various planets. This is the solar family. This is solar family, and after that there is a large number of planets and stars are moving in this universe. This universe, and this universe is nothing but the universe obey the mechanical. This mechanics can be classical mechanics, this can be quantum mechanics, this can be obey statistical mechanics, okay, or relativistic mechanics, but all these universe satisfy one kind of mechanics. Classical mechanics nothing but the special case. This is the special case of different mechanics. They are interconnected to each other. These mechanics are not the separate one. They are interconnected to each other with a special case. At a particular special case, this turns into this and this turns into this, like that. Okay. Now at this moment we can say here the total universe obey this like of mechanics. The universe is does not hand of God or by human purpose. This universe obey the just mechanics. The universe obey the or mechanical principle. So we need to know about the all the mechanics which are already discovered: classical, quantum, statistical, relativistic, etc. Okay. Next is the Galilean transformation or the Galilean invariance. You already we learned there are two type of reference frame: inertia reference frame and the non-inertia reference frame, right? So in case of inertia reference frame, we want to discuss about the Galilean transformation. This is all about the inertia reference frame. Suppose this is a reference frame. This is a reference frame, rest reference frame. This is any reference frame S, denoted by S. This is x axis, this is y axis, and this is z axis. And there is another reference frame. This is known as the S prime, taken as S prime, this x prime, z prime, and y prime, and this moves with speed v. This move with speed v. Then at a particular point, if we consider at a particular point of the this with respect to uh, this rest frame, this is rest and this is uniform motion. This is uniform motion. Uniform motion means this is also a inertia frame and this is also a inertia frame, uniform motion. And this point with respect to rest frame, this will be x, y, z, and with respect to uniform motion frame, this is x prime, y prime, z prime. Okay. Now, if we wants to describe this relation between x prime, y prime, z prime, then you can see here x prime is nothing but this distance is the x prime, and x is nothing but from here, and you can see this distance is nothing but the velocity into time. Velocity into time is this distance. This is the uniform velocity. So from here you can see this x is nothing but x prime plus vt. So x is nothing but x prime plus vt. Clear? X is nothing but x prime plus vt, and the other two, that is y and y prime, is equal. Y and z and z prime also equal, and if we consider t and t prime also equal. In the reverse you can see here in reverse relation you can write x prime equal to x minus vt, y prime equals to y, z prime equals to z, t prime equals to t. Okay, this known as the Galilean transformation. This is actually Galilean transformation, and this is the inverse Galilean transformation. This is the Galilean transformation. Galilean transformation, and this is the inverse Galilean transformation. Inverse Galilean transformation. Clear? Galilean transformation. Okay. So in this transformation, this is transformation between a inertia frame to inertia frame. They both are inertia frame. S and S prime both are inertia frame. Inertia frame. That is their motion either rest or in uniform velocity. Okay. Now what do you mean by Galilean invariance? For that, if you wants to write down the uh, motion, that is any position of this vector, if this is a r vector and this is the r prime vector. If r vector is the position vector with respect to s and r prime is the position vector with respect to r prime, with respect to s prime vector. So you can say here r vector equals to r prime plus this vector, and this is nothing but v I cap, right? V I cap, velocity along this direction v and x is denoted by I cap. So you can see here r vector is nothing but r prime vector plus v I cap. I think clear. R vector is nothing but r prime vector v I cap vector plus r prime vector. So if he wants to find out the velocity, that is the dr dt, that is velocity, this is the position vector, position vector, and if you wants to derivative this position vector, we will be get the velocity. So velocity will be nothing but dr dt. So if you wants to derivative this, so you will get dr prime dt, and since the velocity will be constant, so velocity, sorry, the distance will be t, so vt into I cap, clear? Vt in the distance and I cap will be that distance. V is the velocity, vt will be distance, so vt I cap is the this vector. So if you derivative, so you will get v I cap. So along velocity, this is respect to, this is velocity with respect to rest frame, s frame, right? And this is velocity with respect to s prime frame, and this is velocity of the frame, velocity of s prime frame, with respect to s frame, clear? Now if we wants to find out acceleration, the acceleration, what will be the acceleration? Acceleration will be dv dt. So this is nothing but d2r dt square is equals to d2r prime dt square, and this will be 0. So you can see here the acceleration of the particle with respect to s frame is equal to the acceleration of the particle with respect to s prime frame. Acceleration of the particle of the particle with respect to s frame, s mean rest frame, and the acceleration, this is the acceleration of the particle with respect to s prime frame, right? S prime means the moving frame. So you can see here the acceleration will be the same for these two reference frame. So the acceleration of this particle with respect to s prime is equal to the acceleration of the particle with respect to s prime frame. So if you want to multiply the mass in the both side, you will get the force. So you can see here the force in s frame is equals to force in s prime frame, and force is nothing but the Newton's second law. So you can see here Newton's law of motion is invariance, that is the unchanged. It is valid for both inertia frame. So Newton's law of motion invariance under Galilean transformation. Galilean transformation, clear? So under Galilean transformation, Newton's law of motion has invariance. Invariance means it will be obey the Galilean transformation. Galilean transformation means the transformation between reference frame with the reference frame, that is the reference frame or the inertia reference frame of the moving with the constant velocity. Galilean transformation means the motion of the inertia frame this speed is 0 and this speed will be not 0. This is move with the this is s prime, this move with the constant velocity. Okay, under this transformation Newton's law is valid. But in case of Maxwell equation, you know Maxwell equation, electromagnetic wave, Maxwell's equation. If you don't know, you will be know in future. Maxwell equation is nothing but the divergence of u will be 0. If you know about this in from vector, or if you cover up the vector spiral book, then you know the Maxwell equation in these books. They are written in the question of the fourth chapter, I think. Divergence of v, actually this is not correct. Divergence equal to del b del t, like that. Divergence v will be 0. Curl of e equals to del b del t and so on. Rho by epsilon. This is del b del t. Curl of v is equals to mu naught j plus del e del t. Epsilon naught del e del t. Del e del t. Clear? This like this is this like Maxwell equation, and I think you know del operator is nothing but I cap del del x plus j cap del del y plus k cap del del z, and this is Carl and this is the dot is, you know, this Maxwell equation does not obey the Galilean invariance. That's mean if you find out the this equation in one system is does not, the same relation will be obtained in the another system. Here you can see the force of the S frame will be equal to the force of the S prime frame, but these relation are not obey Galilean transformation. Galilean transformation. Clear? So Galilean transformation does not obey of the Maxwell equation, or you can see of the motion of the particle whose velocity nearly speed of the light. This also does not obey this. Then we need to know the uh, relativistic mechanics. Okay, in this relativistic mechanics will be details where the Galilean transformation is not obey. But at that moment you can conclude that the Galilean transformation invariance, that is the Galilean transformation obey, or this formula, that is the Newton's law of motion, valid in case of the Galilean transformation. Galilean transformation means one inertia frame reference move with a constant speed with respect to a rest frame. This is the Galilean transformation, and this Galilean transformation, under Galilean transformation Newton's law is valid. Okay, so at this moment this is up to that, and in the next class we will be discuss about the this portion, that is the we want to discuss about the equation of motion of this equation, sorry, this portion, the solution of the equation of motion in a simply force field, in a force field. In the force field mean there is a gravitational force field, electrical force field, magnetic force field, this type of force field. So in any force field we want to discuss about the equation of motion in the one dimension, two dimension, three dimension, using Cartesian coordinate system, cylindrical polar coordinate and spherical polar coordinate system. So take care, we will meet in the next class as soon as possible. Thank you.